A transatlantic tunnel would in places sink almost 5 miles below the surface. The pressure at that depth, almost 500 times greater than at the surface, is simply not survivable. And it gets worse. The Mid-Atlantic Ridge, a volcanic undersea mountain range, would be directly in the tunnel's path. The area averages a remarkable 5 earthquakes every day. Drilling in such a seismically active area would be foolhardy at best, deadly at worst. So drilling under the Atlantic Ocean floor won't work. But what if the tunnel could be fabricated in smaller segments on land, then linked together along the ocean floor? This design, known as an immersed tunnel, has been in use for more than a century. The world's longest immersed tunnel was built here in the city of San Francisco in the 1970s. Every day, that city's famous subway, known as BART, takes thousands of commuters across the bay through the world's longest and deepest immersed tunnel. It extends for more than 3.5 miles, sitting 130 feet below the surface, along the bottom of the bay. The tunnel is composed of 57 prefabricated sections, each 24 feet high and 330 feet long. Immersed tunnels have proven safer to build than tunnels bored through the earth. Could an immersed tunnel 1,000 times longer than San Francisco's cross the floor of the Atlantic Ocean? If so, construction might begin here in Holland, at one of the world's largest tunnel factories. With nearly half the country below sea level, the Dutch build more immersed tunnels per square mile than any other nation on Earth.
Imagine you have a large tunnel. It could be a tube or a box-type tunnel. You cut it in pieces. But first you have to build those pieces.
Building an immersed tunnel begins with concrete. Lots of concrete. First, a concrete floor is poured onto a giant preset form. Once the floor dries, the walls and roof can be poured. Each 300-foot-long section of tunnel consumes almost 30,000 tons of steel and concrete. Enough to build a 10-story apartment building. If the concrete dries too quickly, it will become brittle and possibly crack. That's why workers continuously run giant steam generators over the concrete for up to 28 days. When finished, each tunnel section is about the length of a football field. A transatlantic tunnel would require 54,000 prefabricated sections, which would take 225 factories, each working around the clock, 20 years to produce. Of course, building the tunnel sections is only the first step. Then they have to be moved out to sea and pieced together like a huge Lego project. First, each section is sealed tight with steel bulkheads at each end. That makes the sections watertight, so they actually float. Next, the dry dock is flooded, and these massive tubes can be simply towed out to sea.
We can actually float each element out of this dry dock automatically whenever we want.
If these sections were destined for the transatlantic tunnel, they'd be on a very long journey. Sometimes as far as 1,500 miles. This final stage of the process is by far the most difficult and dangerous. And the work must be performed far beneath the surface. Each section is carried to a point directly above its final underwater position by a specialized ship called an immersion pontoon. It is then partially flooded, causing it to sink. Robotic winches control its descent. A team of divers, working in near total darkness, relies on global positioning systems to maneuver tunnel sections to exactly the right spot. The work is very dangerous. If a diver found himself in the wrong place at the wrong time, his air hose could get pinched by a tunnel section and he could suffocate to death. Final placement is critical. Each joint must be lined up precisely on both ends. Huge rubber gaskets are used to form a perfect seal. Immersed tunnels sit in a carved trench to provide a snug fit to the bottom. Once the sections are in place, the bulkhead seals are cut away and the watertight tunnel is complete. This process has been perfected for building underwater tunnels in rivers, bays, and other small bodies of water. But could it be adapted for a transatlantic tunnel? Unlikely. The Atlantic is simply too deep. At just 1 mile down, water pressure is 165 times greater than at sea level. In the deepest ocean, 800 times greater, nearly 12 million pounds of pressure per square inch.
Ordinary tunnel sections would just be crushed to dust in that sort of pressure, which amounts to something like a 747 sitting on a square foot of the tunnel, on every square foot.
There is, however, another kind of tunnel that doesn't lie on the ocean floor. It is an idea that is so new, it has never in fact been tried. But some engineers think this radical design might provide the breakthrough necessary to build the transatlantic tunnel. And it could all happen here, in Norway. This area along the coast is one of the dozens of deep inlets carved by glaciers thousands of years ago. It's an area of Norway characterized by a sweeping natural beauty. But more and more attracts a horde of tourists, causing constant traffic nightmares. Car lines for the ferry snake back for hours. The only alternative is to have your own boat, or risk a treacherous drive around the mountains that can take hours. There are no easy solutions to the problem. The fjord is too deep for a standard immersed tunnel, and local leaders fear that a bridge would be an eyesore. It seemed an impossible situation. Until 1987, when a group of private engineers were ready to test a bold new theory. A tunnel that actually floated, submerged at about 100 feet below the surface. A submerged floating tunnel.
The submerged floating tunnel and the immersed tunnel are very similar, but the immersed tunnel is resting in a trench on the bottom of the crossing. The submerged floating tunnel is suspended in water and has water all around it.
The design is ingenious. Inside the tunnel, a carefully controlled balance of air and ballast enables it to float at a precise depth, in this case 85 feet below the surface.